how we leverage our Ignition infrastructure to get more quick wins. Something I really enjoyed about this project, and Ignition in general, is once the infrastructure is in place, it is easy and flexible to add on to your system. In this particular case, because we were handling all of the work orders, which required us to automatically collect part counts and scrap information, it was very easy to add on an OEE solution. This required us to just start collecting machine downtime and reasons for each piece of equipment. For this customer, we modified PLC logic so that we could collect the downtime as well as the downtime reasons based on faults that existed in the PLC. This allows us to quickly prioritize the faults and see which ones are happening the most frequently and what faults are causing the most duration. We added on a new Sepasoft module, which was the OEE module, and it took about 1 minute to get us out of the box and installed. We then had to, map some tags on the OEE module to the new PLC logic we added, and we were able to get quick wins. So we were able to bring up approximately 40 machines with OEE because we had all of this infrastructure in place already. It took us approximately 2 hours per machine to bring them online, as well as a little bit of overhead time developing our, a PLC template to add on to the equipment so that we could easily map downtime reasons. If we only wanted to monitor downtime and have an operator manually enter the reasons, that would have been a much quicker turnaround. But the automatic downtime reason collection is another huge time saver. It also prevents, different operators from recording different downtime events differently. And it, again, makes a kind of, a one-click solution. Like I showed a few screens ago, you press the start button on a work order and the MES system does the rest. Similarly, with statistical process control, it was another easy add-on. There was a few new pieces of equipment that were fitted with high precision machine vision measurement information. So that we were using cameras to measure, millimeter and sub-millimeter dimensions on certain parts. We were measuring, temperatures and process flows, forces, and, for each particular piece of equipment we were making, we were taking about 60 to 70 measurements. That's all great, except that, if somebody has to review 60 or 70 measurements for 10,000 parts, they're going to be sitting there forever and not know exactly what they need to do. So using the statistical process control model, we were able to set up an SPC sample for each of those 60 to 70 points, and it will tell us things like, are we going out of control? Are we deviating from the mean? Are we trending in one direction or the other? And something else that's really cool about that module is they have what they call a CPP and a CPK tool. And for those of you that are in, manufacturing with dimensional types of devices, you'll know that, oftentimes your customers are going to want that piece of information. It's a statistic that shows that you're capable of producing, what they call a 6 sigma process, so 3 defects per million. I think that's what 6 sigma is. It's been a while since I've looked at the number, but that just comes right out of the box. So you one click and you can send a report off to your client. There's no reason to sit there, tabulate the information into Minitab or Excel, spit out a report and send that along to your customer. And if they were to come in to audit you, if it's a a pharmaceutical customer, you're able to demonstrate that to them on the shop floor, which is a pretty powerful tool. What was cool about this was another piece of equipment was being made in Europe with similar measurement information that was being designed to produce a different part. And we were able to load up a laptop running Ignition. And thanks to Kevin and his team, we were able to get a demonstration license that let us run it for a week. However, even with no license, you are able to run for a couple of hours at a time in demonstration mode. So we sent that on a laptop to Europe, and we were able to FAT that portion of the project before it arrived on site too, which let us start up the equipment in 2 weeks instead of 4, because all of the MES, including the OEE, including the work order handling, was all able to be tested in Europe, and any interfacing between the machine was fixed in the interim. The software was re-downloaded when it got to site, and everything was pretty seamless. So what I'm also excited about with this particular project is what is next. we are currently evaluating machine learning and artificial intelligence to see how we can get more value out of all of the data we are collecting. We talked about SPC and the data points a little bit. So this client is collecting, approximately 1 million data points a month now. And that's growing pretty fast as they're scaling up their production. So we've got a couple of open-ended questions. Can we relate machine parameters to downtime? Can we predict failures? Can we look into process parameters and see how they affect scrap product? We don't have answers to these questions yet, but we have a solid infrastructure in place, and with the unlimited and open nature of the connections and inductive automation's ignition platform, we're going to be finding out soon. Transferring information from their historian or to an SQL database to a cloud-based machine learning platform is seamless. We started to do it, and we're excited to see what results we're going to get.